so welcome back. So we're doing op 4 of this part now, but only on the part that I messed up and I had to re-weld. So you can see we've got it running in the machine here. And we're clearing it out. Now, I've done the simulation on this part and it looks okay. But when it's cutting, you're always a little bit wary. Plus, it works out that when I finish the cutting, or when it starts getting down, it's going to be about 2mm or 1mm above these vice grips. So I want to be on the ball watching it when that happens, because I don't mind scrapping parts, but I'm definitely not into scrapping vices. Now you probably won't see too good from there. If I try and zoom in, you can see with my blurred finger the welded section up here, and over this side it's started to take all that off. So I think I've built up with weld enough of what needed to be built up. I think we might have the odd cavity here and there with a little bit of weld missing, but I think we've got the majority of it. So this cycle is about 55 minutes. It's been running for about 20 minutes. I'll let this run and we'll see how it pans out, and I'll show you what's left when we finish and see if it looks like we're sort of somewhere where we should be. Fingers crossed we will be, but I've picked this up at different points because I've changed the tool path, so I'm hoping it all stays in line and looks like it should do and hasn't gouged anywhere it shouldn't be. So yeah, bring you back when it's finished, we'll see what it looks like. So we're still going. Tickling it out. One bit at a time. I don't think there's long left now. Jobs like this, I really wish I had a new machine that could do high speed and wasn't so jerky on this sort of adaptive toolpath. Okay, so we are almost done. It's just doing the last contour. Inside sections. With that finger, look at that for timing. So let's get the airline. Apologies for noise. Let's see how we look. So, first glance, doesn't look too bad, to be fair. So here's the welded sections, and it appears we've got most of it back. Looks like we've covered the majority. Same on here, we've got a few like cusps. See, we've got a bit of a join in the middle. There's some weld on the underside here, but it's there pretty much. These pocket sections are completely finished on the inside. Obviously this profile is now completely finished. We've got let's try and come over here at this angle. We've got these sections which the tool's actually gone into, and that's for the injector to go in, so they're going to be machined flat. But in general, I'm actually quite chuffed with how this salvageable one is coming out. So we've got a bit more meat on here than perhaps we would have had, because this thinks we'd machined the other side first. So the fact that you've got these cuspy bits sticking out here might be because I put too much meat on it. I'm not sure about here. There's still a bit that could come off. Maybe the tool potentially guessing that the tool, 16mm end mill, might be too wide to get in there. Maybe you could come in, I might even look at programming it to come in with a 10mm and just go around that again, you know, straight down in that profile. But yeah, that is looking okay. I'm happy with that. We haven't gone into the part on these faces yet. I think I was actually under on this face to start with on this one, so we'll have to look at that later. But in general, we're there. So let me just program, what have I got in here? So I'm literally at 19 tools, so I've got one spare spot, which I don't like to put the tool in, because I use that for the probe. So I've actually got one here. That was the big 63mm end mill that previously was coming down when the stock was that way and chomping a load away that we're not using. So I've got one spare spot over there. But I think if I come in with this 10mm end mill here, I could probably come past the halfway section and just do this contour, leaving our 0.5mm, just to get rid of all this. More so when I'm handling the part, I don't cut my finger on it. So let's program that and get that done. Okay, so we're going to come back in with this 10mm tool. It's got 2mm rad on it, and we're going to basically drop below this halfway line. I think I programmed it about 50mm from top of the job, and we're just going to come around and do this profile. It probably shouldn't take much off, to be fair. I might even turn the coolant off and just watch the first bit, because I don't want to have to weld anything up again. I know straight away what we'll have to do is I'll have to move these up out the way. Just so they don't rub on here. Do is use, I'm going to drop the feed rate right down to literally nothing. Sounds stupid, but I'm going to try to see where I'm coming in. Quite as low as I wanted, but I could probably go a bit lower, to be fair. That's what I wanted to see. Yes, I could probably go 2 or 3mm lower. Taking a whisk down that corner. Doesn't look like it's going to hit any of this one. It's just the next two I need to keep an eye on. When it goes round them fuel rail mounts, they're the ones that I'm interested in. So let's just turn the coolant off. bit off this edge. Looking okay. There we go. Gets rid of that bit of excess in there. Just let it go in the other one with coolant. Possibly have a quick look here. I could probably go down another 2 mil, which I may well do. Let's have a look and see what it's looking like afterwards. I may get away with another 2 millimeters, maybe even 3. Look. So you can see there, it cleaned up that edge quite nicely. Could have come a little bit further down on there. Same on that one, cleaned up the edge nicely. So I'm going to look at coming down. Shall I bother? I don't think I need to. I think coming from the other side we would have been fine. So I'm thinking going a bit lower isn't really worth it. I don't think we're going to gain much. So that is it. That's where we're at. It's actually looking like the start of the finished part now. So I was going to take this out and look at the trunnion side of it, and I really want to get it on the table, but part of me is thinking about doing the parallel while I'm here. The parallel can be bolted, the parallel toolpath can be done when it's on the trunnion, and it can be done when it's here. It won't touch this face, it won't touch that face. It's all going to be in between here. So what I'm thinking is, for speed of seeing the finish on this practice part, I'm going to quickly set up, which I've done while the other bit was running, the parallel toolpath, and I'm going to run it in the vices. Then if all is good, I'll flip it over and I'll run the other side in the vices, leaving even less to do on the trunnion. And I may do the parallel on that later, but at the minute I'm just thinking I've got a bit of work stacked up that's got to be done this week. Obviously I've got to go back and look at the table and the machining of the table and alignment and the bearing block and everything like that. It's going to take me probably a good few days to do it. I've got the customer coming in tomorrow about some other parts and another job. So I'm wondering if I can get the parallel path. I wonder if we'll get a look at the potential sort of finished step over, to agree on that. Not to show him the finished part, because we've still got injector holes to do, etc. But we might be able to see where we're at on the step over finish compared to the sample that we brought in. So I'm going to quickly show you the parallel toolpath. Let's just change tools here. I want to see. I just wanted as a guide to see what sort of clearance we've got on this tool, and we've got more than enough, so I haven't got to worry about that. So let's pop back over here to what I've been doing while that was on the go, and then here's the parallel toolpath. So we've gone through and done this to not touch any of these faces, not touch any of the back face. and I've got this sort of 1mm step over, which is pretty much what I think that is. So they've made a couple of things easier on this. I'm coming up here and doing these step overs on this shoulder here, which is a nice, it comes up, it's got a rad and then another radius, so it's all curved. This finished model here, which makes sense, is actually flat. So they've tilted it up and milled straight across, tilted it again, milled straight across. So they haven't worried about ball nosing these, because they've just gone across it with an end mill and gone across that with an end mill, while it's up at, first off will be about that angle, next one up about that angle. My concern there for me, depending on how they held this, they might have been able to bolt this to, they done this on a 5th axis. So they had a whole sort of trunnion turning table, the whole proper shebang, this other company. Whereas I'm going to have a big wide plate. I'm wondering when I'm up at that angle, I'm going to need quite a long tool to get down to do that. But I may well do that, because things like that are where they're shaving off their time. And it's acceptable for the customer, so that's no dramas. But I'm going to do it as per this at the minute and see what the finish comes out like, because you want to see where it's touching, where it doesn't touch, etc. So let's get this in the machine and we will run this program and see what happens. Can't remember what the cycle time was. It's about an hour. No, sorry, because I've done it as a 1mm step over, it's at 26 minutes, but I've got it at a high feed rate. I need to turn that down, so you'll have to ignore the 26 minutes because I don't think I'm going to run it that fast at all. I'll probably run it at half that speed, so it will be more like 40, 50 minutes, say. So let's put the program in here. Still working, calling them vf3.nc. Works every time, and then it still brings up as your, might take a little while to load, but it still comes up as the program number you called it on the Fusion file, which is really good. I don't know how long this is going to take to load because it's a bigger file than usual. But yeah, I'm kind of put it up as 4th axis table slash trunnion slash super duper work, and now I'm doing it all in the vices. But I suppose it's all about getting the finished product the easiest way. I still want to do one on here, and I'm still going to create that table, but I'd like to see where I'm at on this. It will also be a good guide and good reference comparison to see being held this rigid, how that works out compared to just being bolted down with M6 and 2 M10 bolts on the base and having all this hanging free compares, because obviously that's going to be nowhere near as rigid. So there we go, disc done, parallel finish. Now if we look at the program, I've got a feed rate of about 2,000, I believe, and I'm not probably run it at about 1,200 at a guess. So let's see what happens. Hopefully no gouging. First off, it's going to tickle the top. One thing I didn't do, which needs to be done, I did not put the tool into the better holder. So I want to take it out of here and put it in a better holder, because obviously that tool sticking out that far being in a collet chuck is going to be no good. So we'll look at getting that into a better holder and then we'll carry on. So actually I've decided to leave that in there. I'll tell you for why. Because it had already started down here, obviously it's far from the most rigid tool, definitely needs to be changed, but I don't want to have a patch on this one, a patchy area that's got a different finish to everything else. And the problem that you notice, that I've noticed, it's not so much the tool holder's obviously bad, it's that initial engagement. When you've got a millimetre or 0.5 to clear, is when it's coming down. Once he's done that first cut and it's stepping over and cutting on a small percentage of the tool tooth, it's okay. On that initial one, it's almost like plunging all sides of the tool into that 0.5 millimetre or 1 millimetre of stop, depending on where it is. And that's when it's rattling around. So I kind of the initial cuts of the section sound a lot worse. So I'll let this run its cycle. I've slowed the feed rate down. It was programmed at 2000, which is okay when it's doing these bits, but it's not okay at the start. So I've slowed it down to 1200. We're dropping, it was programmed at 6500 RPM, and I've dropped that down to 58, because if you up the spindle, it just doesn't sound a lot of difference, but we'll see. So let's let this play out. I'll show you what it's like when we're done, and then we'll look at getting our 10mm hydraulic holder here. I think, yeah, these are Ericsson ones. Got these in an auction, so they're not new, but they do work well. And we'll look at how short I can cut that tool down. Once again, there's the tool. Oh, so it's 180mm long with a 60mm throat on it, 60mm reduced shank. So I'll look at how much I can cut it down, because obviously we've got a long reach in here, and we've just got to make sure everything clears the part. So we'll let this one rattle out, and we'll go from there. Okay, so we finished doing the rattly parallel toolpath in the poor ER32 collet holder. Excuse me, I'm just literally setting up a little job on my other machine here that I've just got to check. But yeah, we finished the toolpath on the other thing, and I've not looked at it yet, but I'm going to show you. So we'll see how bad and rattly it actually is once I get this one started. Right, so yeah, this is just finished. Apologies, but I want to blow all the coolant off it so we can at least get a half decent look at it. Right, what we got? Okay. Not actually too bad, I'll be honest with you. Obviously we've got all this going on here, which they haven't got because they put the two flats on their pieces, but I can probably do something with that. Now, there's a couple of things here that are going to be, you kind of got to wing it, because you've got what you'd kind of call like a gouge mark here, but on the other hand, I done this with no stock to leave, and I'm actually going to come in. This should have a millimetre or so stock to leave, but I've done the parallel with no stock to leave now, so I'm probably going to have to come in, well, I will come in afterwards and put a flat face on these, which is probably going to get rid of the majority of that. It's going to leave a bit of a witness on there, but I think it will get rid of a lot of it. I'll show you what I mean. If we grab this one, so you see here, very similar. So let's just carefully lay that down. Oh, they're not looking far off now, are they? So you can see here they've come into this with an end mill. For example, let's just use this as a flat face, and they've come in with a rad tool, and it's just gone along and put that flat face on. Now, at the minute, I've still got stock to leave here, so I can clean this, so that will be cleaned up, not I can clean it up, it will be cleaned up when these are done with a flat face. The same here, where the tool path is licking around here, obviously they come in, you can see that there was a few tool marks, areas, and they've been tidied up by this flat face here, which is, I think I'd like to do that. I can see why they've done it now, makes sense. But you can see that there's cusps in these corners. Now, as far as that horrendous rattly noise goes, that is where it's in here, biting into this corner in one hit. But it's actually, I'm happy with that. That's okay. I'm not going to get a proper look at this until I take it out of the vise, but as far as tool marks go, I think that's okay. Can't really see too well on the back side here, but same thing, you can see where it's rattled in the corners. So yeah, it's not as bad as I thought. Now, one thing I just want to try to work out is whether I'm at the halfway mark. You can see these actually turned out well, the ones that were welded back up. We've got pretty much all our material there, I believe. You can see a bit of pitting in there where the weld didn't get in, but again, it's a sample. As a first off prototype, the welding salvaged it pretty good. Now, I just don't think I'm halfway with these tool lines, and you can see there a culmination of vibration, maybe the speed too fast. So we're definitely going to change this out of this holder. So you see we've got a reduced neck there, and obviously I'm in a collet. Cheap, this is a £15 holder, so we're going to change that. And actually thinking about it, I said I was going to put it into one of these, but I'm not, because even that stick out is excessive and it doesn't need it, and of course the tool only sits in so far. So I think what I'm going to do, I don't have a short one like this in the 10mm, but I do have a YG hydraulic holder, which I thought was in here. Yes, it's here. So I'm going to swap this tool into a standard 10mm holder, and then I will take this hydraulic and I'll put that in it, and I'll cut this down to suit the length. But I'm thinking that I need to go a little bit deeper. I'm not quite there yet. I think I need to go further down. I think I need to go further down, because I'm worried that if I flip it over, I'm worried it isn't going to touch. should be able to get 50-50. But that doesn't look like it's going to be, or is it? Is that halfway in the centre of this? The last thing I want to do is have a missed mark in the middle. So we are getting there. We're most certainly getting there. But I need to sort out the vibration in this holder. Then I need to sort out whether I'm down halfway, and then flip it over and do the same off on the other side. So yeah, we're not quite there yet, but I think the vibration will sort out the finish. Step over is about the same. Step over is about the same. I just want a much better finish on that, and then I'll be quite happy. So yeah, let's get this holder swapped around and cut down, and then I'll probably run another pass on here, but lower. Okay, so I've come back this evening, went home, wait till the kids gone to bed, and I've come back to work because I wanted to crack on with this part and see what sort of finish we could get. So we changed the tool, as mentioned, into a hydraulic holder, and it certainly cleaned up the finish in the corners with a second pass. Not sure how much better it's going to be on the first initial pass, but then on the other end it's kind of just going to be rubbing because we've already removed the material. It made one bit of contact there, and when I looked back it didn't show that as touching, but it had a linking move which lifted from here and went across to the next piece. I don't know why it's touched, but I've now done a full retract, which added 2 minutes to the program, but means it's going to come well away. So we should be able to avoid that next time without any issues. So we're going to take this out of here now, and we're going to flip it over. I'm just going to upload the next side. And in comparison, obviously the next side's much more basic. I wonder if any of you guys know, is there a better tool to use than this insert IX mill type that we've got there? You know, is there something better I should be using for this? Either something that's gonna, it's got to be relatively small to get in there, but something that's going to be more rigid, or, you know, I've no experience for finishing these sort of parts. So let's undo this, we can have a bit of a better look. Let's take that out of there. I've got my parallels just sat on the back side. Take them out, hopefully without dropping the part. So there's one side. Obviously we've got to do these faces and we've got to do that face, but we're now going to flip it over and clean up this side. So let me get this bolted in the machine. It's going to sit that way up, and obviously run the same sort of passes. So yeah, let's get it bolted in the machine and get this program running, and then we'll see what it looks like after this side's done. Okay, so we've flipped it over in the vices, and we're ready to machine. Now, the only thing that kind of bothers me is that this has got stock to leave of 0.5 mil. It's either 0.5 millimetre or 1 millimetre. Can't remember what I just looked at now, but when it comes down and comes up, this initial side is going to be, it's probably going to be quite noisy in there. So I'm going to have to, we'll have to see how it goes, because you're not going to be able to finish these. I can't work out a way to finish these until this is bolted down and it's up at a very slight angle, and then we can get to it. We'll have to use multi-axes. So I'm going to have to see how this sounds at the start. And we've got to come down 60 or 59 millimeters to be able to get the other side of this. So we'll have to see how that goes as well. So although this is the simple side, but hasn't got as much going on, it's actually going to be more complex in some senses. It's going to feed it really nice and easy. And I also want to see that is the bit. We might even get a bit of tool rub. Might get a bit of tool rub on the back there like we did previously anyway, but as long as we can finish it afterwards somehow, I'm hoping we're good. Because when you look at this piece, so we're currently machining, currently looking at it like that. Now you see there they've got a lovely finish, and you can see the lines are kind of parallel along that face, and then they just ride up the fillet or radius, whatever you want to call it, of the actual inlet tract. So I'm wondering if they had it turned up on their fifth axis, you've only got to have it like there and you can get to all of that all the way down, because it's not very deep down there. So that side, looking at it, looks easier. This side, when it's bolted down, I don't know how they've done this, because it's very, very fine steps. Maybe they done the same thing, half from that side and then angled and done half from the other side. So I'm going to ignore, well, I have to ignore the finish on them faces at the minute. We'll have to look at that afterwards. But one more thing that I've just sort of come back to, that obviously I bought this extended table, which is all well and good, but now I'm looking at the finished part with the parallel toolpath completed. Maybe I can squeeze it on here and give myself enough room, because we need to get down to this side with a tool. But for example, these are my longest reach tools that I have. I may have to buy something different. So if you see there, if you imagine this being tilted in the 4th axis. I want to be able to get to half of that, which I can. I can get to that in there. Obviously I can get into here, that's no problem. So I actually wonder if I need to use the extended table or whether I'll get away with this shorter one. When we come up and do the back side, we'll have to be sort of here. But again, I may just about get away with it. This bit won't be no issues. So, yeah, maybe the shorter table. Or maybe just a little bit longer. But we'll have to have a look at that afterwards. So this has just gone in there. 55-minute cycle time. Could probably run this one a bit quicker, but there's no point in me going flat out. So we're going to let this run 55 minutes. It's now, I think it's about 11:15 at night. So I'll run this till 10 past midnight maybe. There's that very first pass again, up against the flange. First run when he's taking that pipe pretty much gives me a heart attack, and then it quiets down, it's back into normal cut. But yeah, we'll let this run for an hour and I'll show you when it's done and we'll see what we're looking like. Okay, so this op has just finished. So let's have a look. Okay, so the finish is pretty good. We've definitely made our overlap, which is nice. We've got a nice finish on that fillet section there. Now this, remember, is still oversized because I'm trying to work out how to come back in and machine this nice. So ignore this finish and where the shoulder's rubbed on the tool there. We're concentrating on this fillet, making sure that looks okay, not too rattly, and that we haven't got too many bad tool marks. And obviously here, where we have met up with these, I'm actually really happy with that. Yeah, that's come out quite nice indeed. Do I have to do anything while it's in here? Just thinking to myself, we can't do this face, we can't do that face. We've done this. Right, I'm going to take it out because we can't do any more on there. And as mentioned earlier, I was about right at the timing. I was just finishing off something else as well, and it's about 20 past midnight. Just gone 20 past midnight maybe. Get some of the coolant off this, and then we'll go sit down and we'll have a little look at it. Let's go and inspect our masterpiece, he says. Let's go this way. I was looking for a towel, to be fair. Got a bag of towels there. Grab a towel, just give it a wipe over. Let me just dry this off and I'll bring you back. Okay, so we've just dried that off. Just didn't want to sit here with it on the bench, dripping coolant everywhere. Now, you can see better angles, certain parts of this now, and we can see what we're looking like. Now, you can see these pieces, actually the weld filled in 99.9% of what I accidentally took off. There was about a millimetre to come off this face, I believe. So that will get rid of these cusps and this finish here. Give us a nice flat machine face. The same on this one, you've got these sort of step cusp marks. I would really love to be able to program this, and I don't know how to do it, to just come over one continuous, because it does bits and pieces here, then it moves over here. I'd love it to just go from one side all the way to the next, like dropping in and out. That would be awesome. But it's done well. I'm actually quite happy with it. So in here we've got our machined marks, which, to be honest with you, you could leave them. You've got cusp marks here, so if we want to be picky and compare it to another company's 5-axis job that this was done on, they still have, see in the corners, they've got a lot of cusp marks down here. This side they've got really nice and neat. There's a few marks that they've got in the part. Obviously they had the same sort of cusp marks in there before they machined that flat. But yeah, in general, I'm not doing bad compared, I don't think. That's what you see around here. Again, a lot of big cusp marks that they've got there. So, nobody's perfect. They've got that side much better. This side, not so good. So yeah, I'm happy with my result. It's definitely not as efficient as their 5-axis, I'm sure. But with a comparison, they've got a better finish. Oops. I say that, I quite like my finish as well. So there isn't a lot in it really, is there? Let's be honest. There's definitely not a lot in it. See, they haven't gone as deep with this either. They've gone quite shallow with that, whereas I've gone quite deep with that as per the model. So I'm not sure why they haven't gone as deep. It fits the car, so it obviously isn't needed, but we've got a little bit more material out on here. And also I think I'm narrower. So you see on their one how they've just come in and they've left. Right, so they've come in and they've left the meat here. Look, they've gone right round with the cutter, and they've left all that meat on the inside there, whereas on my one it's gone as per the model. So I've taken off more material. Now I haven't got the holes drilled, but I've got a face off here. We need to drill and tap these holes. I've still got to take the back angle off of here, the angle off the top, the angle off the very front of this. I need to finish these bores, so there's about 0.25 or 0.5, sorry, in these bores. Face off these holes, face off the flanges. So I've got a little bit of work left, and let's compare them. Right, I've got my vices over here actually. Picked up two more big Hilmer vices. These are the big chunky 160s compared to my 125s over there. If I move some of this stuff. If I move some of this, let's put the scales on here. So let's get our scales out. See where we're at. Okay, so the supplied finished item given to me by the customer as the sample, we're at 2.226 kilos. 2.226. Take that one off. And unfinished, $2.234. So by the time we took a little bit of meat out of here, took this out of here, finished our flanges, we're going to be just under their weight, which probably makes sense as they left theirs oversized on these inlet tracks, as far as I can tell. But we are thereabouts. We started off with 20 kilos and we're now at 2.2 kilos. So yeah, not so bad. It's a lot of wastage, but needs must. So here's where I have to come back in and wait now until I do sort out something for the fourth axis, because I am, every time I said I'm going to put it on the fourth and we do another op in the vise, another op in the vise, unless I now move to an angle plate or a fixture, I am done in what I can do in the vices, because we now need to start tilting it at an angle, and it would be really good, and that's what we want to do in the fourth axis. From what I quickly mocked up from the model, to allow me to machine into this inlet, and basically it's getting these back corners, and you can see that step there and the step in the opposite direction there. To get to them, I needed to be able to tilt this 3 degrees. I think I worked it out, 3 degrees each way. So if I tilt it that way, I can get to one end and machine that section away that you can't see there. And if I tilt it the other way. The other way I probably don't need to. It's probably just that one way I need to tilt it, because I need to be able to smooth out these bores, give us a really nice finish. They've got a really nice finish on the inside of their bore. Obviously they were done on a 5-axis machine, so they could quite happily come in with a ball nose and move the whole thing around, which I'm not able to do that. So I'm hoping a little bit of tilt one way and a little bit of tilt the other way is going to give me the access to get in there to do that. Obviously these were just the rough finishes, so ignore them. That is purely roughing out. But yeah, that's where we're at. So it's going to be a case of getting to this point using the vices, and then everything from this point onwards is going to be the 4th axis. And it isn't even going to need to be simultaneous 4th axis, I don't think, to get in these areas, but we definitely need to be on the 4th axis for the angles we want. So the injector angles are going to be quite straightforward. To cut that face there, and I'll probably do the same as what they done with regards to cutting a flat face here. This bit maybe not so much, but definitely going around here, and that will clean up this area with these cusps. This step here, you could leave that as machine marks. You could take it away. I'll ask the customer tomorrow, and then obviously we can come in on these injector faces and machine them off. So yeah, we're nearly there. There's going to be a bit of a break in the videos now because I'll have to do the 4th axis stuff. I'll obviously film what I do, how I true it up, how I get it working, and then I'll get into filming how I actually do the toolpath, because as far as that goes, I don't actually know myself. I'm not sure how anything that's done on the 4th axis, it's not on the older stuff, it's not. From what I've googled on new stuff, you can have dynamic work offsets, something like that, where you can put your offsets wherever you want and tell it how the part's going to move around, what, where, when. When you're using just the generic 4th axis setup, the centre of rotation has to be the centre of the 4th axis, so it has to be along the x-axis through the A rotation, so the centre of the rotary table. But of course, if you're sitting on a table, if you've got this part sat on the table, the centre of rotation, you're going to have to work out, I'll have to probe it, I guess, because the centre of rotation could be sort of at this height. So then I'll have to have some mock-up sketch on the part floating out here to tell it where the centre of rotation is. Once you've got that, the rest of it won't be too bad, because I could clock off this bore for X, Y, if I know I'm centered. Or do you center? Surely you'd center Y off the bed, as in the bed of the 4th axis trunnion. Z will be the center of rotation, or A will be the center of rotation, and then as for X, I can put X anywhere, really. So I want to touch off the part so we know exactly where we're at. So I'd probably touch off the side here, finish side here, then Y, we'd have to make sure that this bolt pattern is in the center. We'd have to make sure this bolt pattern is in the center of the table, which is about 150 millimeters wide, so it's easy to center up that. Once the table is machined and it's flat, and we've clocked it and it's flat, then we can center in Y, center in Z, rotation of the 4th axis, and then X we can come off the side of the part. That's what I'm thinking anyway. Sorry about that complete waffling to myself, just thinking how I assume it's going to be done. That may be incorrect, so I may have to look into something else for that. So yes, thank you very much for watching the video. As mentioned before, please like and subscribe. Trying to build up the subscribers on the channel. It'd be great if you can hit that subscribe button, because most of the people who watch this aren't subscribers. I think it's about 10% of you do subscribe and the rest are just sort of passing through. But if you would give me a subscribe, that would be fantastic. And I hope you enjoyed watching, and we will bring you back for the next video when we finally, I promise, we will get onto the fourth axis on that table. But it's going to take me a few days to get that sorted and set up, I think. So yeah, cheers for watching, and we'll see you again soon.